So in this video, we are going to discuss the problem power of 2, which is problem number 231 in Leetcode. In this question, an integer n is given. We need to return true if it is a power of 2, or else we are going to return false. Let's see the test cases. The first one is n equal to 1. As we know, 2 power 0 equal to 1, 2 power 1 equal to 2, 2 power 0 is 1 here. So 1 can be written as power of 2. So we are going to return true. Then taking 16, we know 2 power 2 equal to 4, 2 power 3 equal to 8 and 2 power 4 is equal to 16. So 16 can be written as 2 power 4. So we are going to return true. Then coming to the next test case, it is n equal to 3. We know here 2 power 1 is 2 and 2 power 2 is 4. There is no 3 which can be written as 2 power in powers of 2. So we are going to return false. Now let's solve it using loops first. We are going to take an input def is power of 2. So here, as we can see, there is a corner case, that is when it is 0. When it is 0, how would we check? So there is no condition to check 0. We are going to write if n is equal to 0, we are going to directly return false. Now if we are going to write while loop. While n is greater than 1, we are going to check if n modulo 2 is not equal to 0, then we are directly going to return false, or else we are going to do n by equal to 2. Finally, out of while loop, we are going to return true. So what exactly happens is, here let's take an example of 6, 3 and 8 for this code. When we take 6, what happens is it enters the loop, n modulo 2 will be checked, that is 6 modulo 2, which is equal to 0. Then n is going to be divided by 2. So what happens? Now n is equal to 3. Again it goes into the loop. Now it checks 3 modulo 2. We get here 1. So it returns false. For 3, it directly goes into the loop and checks 3 modulo 2, which is 1. So here it returns false. For 8, it checks 8 modulo 2 equal to 0. Now it becomes 4. 4 modulo 2 equal to 0. Now it becomes 2. 2 modulo 2 equal to 0. Now it becomes 1. Since 1 is equal to 1, it doesn't go into loop. It goes outside and it returns true. So in this way, we can do an iterative approach with loops. Now let's do a recursive one. What changes in recursive one is, instead of this thing, we are going to return . here return is power of 2 of n by 2, and here we are also going to add a condition that if n equal to 1, we are going to return true. So what happens if the case it is 3? Initially it checks these two conditions, it doesn't satisfy, then 3 by 2. 3 by 2 is 1. 3 by 2 would be 1.5. So 1.5 goes inside, it checks, it doesn't work, then it goes to 0.75, and finally it goes to 0. 0, here we are going to get false. So for 3 it's going to be false. Next, now coming back to our question, in Leetcode we are going to have a follow-up thing here. Follow-up here is to solve the question without using loops or recursion. So without using these two approaches, we need to solve it. So how can we solve it? We have a topic called bit manipulation, in which we deal with binary representations of numbers. And we also use binary operators. To solve the above problem, we can do it in this way. Initially when n equal to 0, we are going to directly return false, which is same for above two codes also. Here what is new is this logic. So now let's take 3 and 4. What happens for 3 is it's going to check the bitwise AND of 3 and 2. The binary representation of 3 is 0, 1, 1. The binary representation of 2 is 0, 1, 0. If we perform AND of these two, we are going to get 0, 1 and 0, which is not equal to 0. So it's going to return false. Now let's take 4. It's going to take 4 and 3 here because n minus 1. The binary representation of 4 is 0, 1, 0, 0, and for 3 it is 0, 1, 1. If we perform AND here for these operators, we are going to get 0, 0, 0, which is equal to 0. So here it returns true. In this way, we can find whether a number is power of 2 or not. Let's try it for 6 and 5 also, because you may have a doubt, will it be true for all even numbers? Let's check it using 6 and 5. What would be the representation of 6? It would be 1, 1, 0. And what would it be for 5? It would be 1, 0 and 1. Now if we perform AND, we are going to get here 1, 0, 0, which is not equal to 0. So we are going to get false here. So this is the most optimized approach for this problem, which has a complexity of O of 1. So this topic of bit manipulation is very useful in solving these kind of questions. Thank you, and if you have any other question which you want me to solve, then please comment.